Make pixels dance, high dynamic video generation. Creating high dynamic videos, such as motion-rich actions and sophisticated visual effects, poses a significant challenge in the field of artificial intelligence. Unfortunately, current state-of-the-art video generation methods, primarily focusing on text-to-video generation, tend to produce video clips with minimal motions, despite maintaining high fidelity. We argue that relying solely on text instructions is insufficient and suboptimal for video generation. In this paper, we introduce Pixel Dance, a novel approach based on diffusion models that incorporates image instructions for both the first and last frames in conjunction with text instructions for video generation. Comprehensive experimental results demonstrate that Pixel Dance trained with public data exhibits significantly better proficiency in synthesizing videos with complex scenes and intricate motions, setting a new standard for video generation. Exponentially faster language modeling. Language models only really need to use an exponential fraction of their neurons for individual inferences. As proof, we present FastBERT, a BERT variant that uses 0.3% of its neurons during inference while performing on par with similar BERT models. FastBERT selectively engages just 12 out of 4,095 neurons for each layer inference. This is achieved by replacing feed-forward networks with fast feed-forward networks, FFFs. While no truly efficient implementation currently exists to unlock the full acceleration potential of conditional neural execution, we provide high-level CPU code achieving 78 times speedup over the optimized baseline feed-forward implementation, and a PyTorch implementation delivering 40 times speedup over the equivalent batched feed-forward inference. We publish our training code, benchmarking setup, and model weights on the project's website. MultiLoRA, Democratizing LoRA for better multitask learning. LoRA achieves remarkable resource efficiency and comparable performance when adapting LLMs for specific tasks. Since ChatGPT demonstrated superior performance on various tasks, there has been a growing desire to adapt one model for all tasks. However, the explicit low rank of LoRA limits the adaptation performance in complex multitask scenarios. LoRA is dominated by a small number of top singular vectors, while fine-tuning decomposes into a set of less important unitary transforms. In this paper, we propose MultiLoRA for better multitask adaptation by reducing the dominance of top singular vectors observed in LoRA. MultiLoRA scales LoRA modules horizontally and change parameter initialization of adaptation matrices to reduce parameter dependency, thus yields more balanced unitary subspaces. We unprecedentedly construct specialized training data by mixing datasets of instruction follow, natural language understanding, world knowledge to cover semantically and syntactically different samples. With only 2.5% of additional parameters, MultiLoRA outperforms single LoRA counterparts and fine-tuning on multiple benchmarks and model scales. Further investigation into weight update matrices of MultiLoRA exhibits reduced dependency on top singular vectors and more democratic unitary transform contributions. Orca 2, Teaching Small Language Models, How to Reason. Orca 1 learns from rich signals, such as explanation traces, allowing it to outperform conventional instruction-tuned models on benchmarks like Big Bench Hard and ArxivDailyShow. In Orca 2, we continue exploring how improved training signals can enhance smaller LMs' reasoning abilities. Research on training small LMs has often relied on imitation learning to replicate the output of more capable models. We contend that excessive emphasis on imitation may restrict the potential of smaller models. We seek to teach small LMs to employ different solution strategies for different tasks, potentially different from the one used by the larger model. For example, while larger models might provide a direct answer to a complex task, smaller models may not have the same capacity. In Orca 2, we teach the model various reasoning techniques, step by step, recall then generate, recall reason generate, direct answer, etc. More crucially, we aim to help the model learn to determine the most effective solution strategy for each task. We evaluate Orca 2 using a comprehensive set of 15 diverse benchmarks, corresponding to approximately 100 tasks and over 36,000 unique prompts. Orca 2 significantly surpasses models of similar size and attains performance levels similar or better to those of models 5-10x larger, as assessed on complex tasks that test advanced reasoning abilities in zero-shot settings. We open-source Orca 2 to encourage further research on the development, evaluation, and alignment of smaller LMs. Adapters, a unified library for parameter-efficient and modular transfer learning. We introduce Adapters, an open-source library that unifies parameter-efficient and modular transfer learning in large language models. By integrating 10 diverse adapter methods into a unified interface, Adapters offers ease of use and flexible configuration. Our library allows researchers and practitioners to leverage adapter modularity through composition blocks, enabling the design of complex adapter setups. We demonstrate the library's efficacy by evaluating its performance against full fine-tuning on various NLP tasks. Adapters provides a powerful tool for addressing the challenges of conventional fine-tuning paradigms and promoting more efficient and modular transfer learning. The library is available via the project's website. System 2 attention is something you might need too. Soft attention in transformer-based large language models, LLMs, is susceptible to incorporating irrelevant information from the context into its latent representations, which adversely affects next token generations. To help rectify these issues, we introduce System 2 Attention, S2A, which leverages the ability of LLMs to reason in natural language and follow instructions in order to decide what to attend to. S2A regenerates the input context to only include the relevant portions, before attending to the regenerated context to elicit the final response. In experiments, S2A outperforms standard attention-based LLMs on 3 tasks containing opinion or irrelevant information, QA, math word problems, and long-form generation, where S2A increases factuality and objectivity and decreases sycophancy. Memory-augmented language models through mixture of word experts. Scaling up the number of parameters of language models has proven to be an effective approach to improve performance. For dense models, increasing model size proportionally increases the model's computation footprint. In this work, we seek to aggressively decouple learning capacity and floating point operations, FLOPs, through mixture of experts, MOE-style models, with large knowledge-rich vocabulary-based routing functions, and experts. Our proposed approach, dubbed Mixture of Word Experts, MOW, can be seen as a memory-augmented model, where a large set of word-specific experts play the role of a sparse memory. We demonstrate that MOE performs significantly better than the T5 family of models, with similar number of flops in a variety of natural language processing NLP tasks. Additionally, MOE outperforms regular MOE models on knowledge-intensive tasks and has similar performance to more complex memory-augmented approaches that often require to invoke custom mechanisms to search the sparse memory. The LucidDreamer, towards high-fidelity text-to-3, degeneration via interval score matching. The recent advancements in text-to-3 degeneration mark a significant milestone in generative models, unlocking new possibilities for creating imaginative 3D assets across various real-world scenarios. While recent advancements in text-to-3 degeneration have shown promise, they often fall short in rendering detailed and high-quality 3D models. This problem is especially prevalent as many methods base themselves on score distillation sampling, SDS. This paper identifies a notable deficiency in SDS, that it brings inconsistent and low-quality updating direction for the 3D model, causing the over-smoothing effect. To address this, we propose a novel approach called interval score matching, ISM. ISM employs deterministic diffusing trajectories and utilizes interval-based score matching to counteract oversmoothing. Furthermore, we incorporate 3D Gaussian splatting into our text-to-3D generation pipeline. Extensive experiments show that our model largely outperforms the state-of-the-art in quality and training efficiency. text-to-sticker style tailoring, latent diffusion models for human expression. We introduce style tailoring, a recipe to fine-tune latent diffusion models, LDMs, in a distinct domain with high visual quality, prompt alignment, and scene diversity. We choose sticker image generation as the target domain, as the images significantly differ from photorealistic samples typically generated by large-scale LDMs. We start with a competent text-to-image model, like EMU, and show that relying on prompt engineering with a photorealistic model to generate stickers leads to poor prompt alignment and scene diversity. To overcome these drawbacks, we first fine-tune EMU on millions of sticker-like images collected using weak supervision to elicit diversity. Next, we curate human-in-the-loop (ITL) alignment and style datasets from model generations and fine-tune to improve prompt alignment and style alignment respectively. Sequential fine-tuning on these datasets poses a trade-off between better style alignment and prompt alignment gains. To address this trade-off, we propose a novel fine-tuning method called style tailoring, which jointly fits the content and style distribution and achieves the best trade-off. Evaluation results show our method improves visual quality by 14%, prompt alignment by 16.2%, and scene diversity by 15.3%, compared to prompt engineering the base EMU model for stickers generation. AutoStory, generating diverse storytelling images with minimal human effort. Story visualization aims to generate a series of images that match the story described in texts, and it requires the generated images to satisfy high quality, alignment with the text description, and consistency in character identities. Given the complexity of story visualization, existing methods drastically simplify the problem by considering only a few specific characters and scenarios, or requiring the users to provide per-image control conditions, such as sketches. However, these simplifications render these methods incompetent for real applications. To this end, we propose an automated story visualization system that can effectively generate diverse, high-quality, and consistent sets of story images with minimal human interactions. Specifically, we utilize the comprehension and planning capabilities of large language models for layout planning, and then leverage large-scale text-to-image models to generate sophisticated story images based on the layout. We empirically find that sparse control conditions, such as bounding boxes, are suitable for layout planning, while dense control conditions, for example sketches and key points, are suitable for generating high-quality image content. To obtain the best of both worlds, we devise a dense condition generation module to transform simple bounding box layouts into sketch or key point control conditions for final image generation, which not only improves the image quality but also allows easy and intuitive user interactions. In addition, we propose a simple yet effective method to generate multi-view consistent character images, eliminating the reliance on human labor to collect or draw character images. GPQA, a graduate-level Google-proof Q&A benchmark. We present GPQA, a challenging dataset of 448 multiple-choice questions written by domain experts in biology, physics, and chemistry. We ensure that the questions are high quality and extremely difficult. Experts who have or are pursuing PhDs in the corresponding domains reach 65% accuracy, 74% when discounting clear mistakes the experts identified in retrospect, while highly skilled non-expert validators only reach 34% accuracy, despite spending on average over 30 minutes with unrestricted access to the web. That is, the questions are Google-proof. The questions are also difficult for state-of-the-art AI systems, with our strongest GPT-4-based baseline achieving 39% accuracy. If we are to use future AI systems to help us answer very hard questions, for example, when developing new scientific knowledge, we need to develop scalable oversight methods that enable humans to supervise their outputs, which may be difficult even if the supervisors are themselves skilled and knowledgeable. The difficulty of GPQA, both for skilled non-experts and frontier AI systems, should enable realistic, scalable oversight experiments, which we hope can help devise ways for human experts to reliably get truthful information from AI systems that surpass human capabilities. ToolTalk, evaluating tool usage in a conversational setting. Large language models, LLMs, have displayed massive improvements in reasoning and decision-making skills and can hold natural conversations with users. Many recent works seek to augment LLM-based assistants with external tools so they can access private or up-to-date information and carry out actions on behalf of users. To better measure the performance of these assistants, this paper introduces ToolTalk, a benchmark consisting of complex user intents requiring multi-step tool usage specified through dialogue. ToolTalk contains 28 tools grouped into 7 plugins and includes a complete simulated implementation of each tool, allowing for fully automated evaluation of assistants that rely on execution feedback. ToolTalk also emphasizes tools that externally affect the world rather than only tools for referencing or searching information. We evaluate GPT 3.5 and GPT 4 on ToolTalk, resulting in success rates of 26% and 50% respectively. Our analysis of the errors reveals 3 major categories and suggests some future directions for improvement. We release ToolTalk at the project's website. TPTU V2, boosting task planning and tool usage of large language model-based agents in real-world systems. Large language models, LLMs, have demonstrated proficiency in addressing tasks that necessitate a combination of task planning and the usage of external tools that require a blend of task planning and the utilization of external tools, such as APIs. However, real-world complex systems present 3 prevalent challenges concerning task planning and tool usage. 1. The real system usually has a vast array of APIs, so it is impossible to feed the descriptions of all APIs to the prompt of LLMs, as the token length is limited. 2. The real system is designed for handling complex tasks, and the base LLMs can hardly plan a correct subtask order and API calling order for such tasks. 3. Similar semantics and functionalities among APIs in real systems create challenges for both LLMs and even humans in distinguishing between them. In response, this paper introduces a comprehensive framework aimed at enhancing the task planning and tool usage, TPTU, abilities of LLM-based agents operating within real-world systems. Our framework comprises 3 key components designed to address these challenges. 1. The API retriever selects the most pertinent APIs for the user task among the extensive array available. 2. LLM fine-tuner tunes a base LLM so that the fine-tuned LLM can be more capable for task planning and API calling. 3. The demo selector adaptively retrieves different demonstrations related to hard-to-distinguish APIs, which is further used for in-context learning to boost the final performance. We validate our methods using a real-world commercial system, as well as an open-sourced academic dataset, and the outcomes clearly showcase the efficacy of each individual component, as well as the integrated framework. $Circumflex, $2, UGen, multimodal music understanding and generation with the power of large language models. The current landscape of research leveraging large language models, LLMs, is experiencing a surge. Many works harness the powerful reasoning capabilities of these models to comprehend various modalities, such as text, speech, images, videos, etc. They also utilize LLMs to understand human intention and generate desired outputs like images, videos, and music. However, research that combines both understanding and generation using LLMs is still limited and in its nascent stage. To address this gap, we introduce a multimodal music understanding and generation (M2 UGen) framework that integrates LLM's abilities to comprehend and generate music for different modalities. The M2 UGen framework is purpose-built to unlock creative potential from diverse sources of inspiration, encompassing music, image, and video through the use of pre-trained MIRT, VIT, and VIVIT models, respectively. To enable music generation, we explore the use of Audio LDM2 and MusicGen. Bridging multimodal understanding and music generation is accomplished through the integration of the Llama 2 model. Furthermore, we make use of the MultiLoRA model to generate extensive datasets that support text/image/video to music generation, facilitating the training of our M2 UGen framework. We conduct a thorough evaluation of our proposed framework. The experimental results demonstrate that our model achieves or surpasses the performance of the current state-of-the-art models. ProAgent, from robotic process automation to agentic process automation. From ancient water wheels to robotic process automation, RPA, automation technology has evolved throughout history to liberate human beings from arduous tasks. Yet, RPA struggles with tasks needing human-like intelligence, especially in elaborate design of workflow construction and dynamic decision-making in workflow execution. As large language models, LLMs, have emerged human-like intelligence, this paper introduces Agentic Process Automation, APA, a groundbreaking automation paradigm using LLM-based agents for advanced automation by offloading the human labor to agents associated with construction and execution. We then instantiate ProAgent, an LLM-based agent designed to craft workflows from human instructions and make intricate decisions by coordinating specialized agents. Empirical experiments are conducted to detail its construction and execution procedure of workflow, showcasing the feasibility of APA, unveiling the possibility of a new paradigm of automation driven by agents. Our code is public at the project's website. GPT-4V, ision, for Robotics, Multimodal Task Planning from Human Demonstration. We introduce a pipeline that enhances a general-purpose vision language model, GPT-4V, ision, by integrating observations of human actions to facilitate robotic manipulation. This system analyzes videos of humans performing tasks and creates executable robot programs that incorporate affordance insights. The computation starts by analyzing the videos with GPT-4V to convert environmental and action details into text, followed by a GPT-4-empowered task planner. In the following analyses, vision systems reanalyze the video with the task plan. Object names are grounded using an open vocabulary object detector, while focus on the hand-object relation helps to detect the moment of grasping and releasing. This spatio-temporal grounding allows the vision systems to further gather affordance data, for example, grasp type, waypoints, and body postures. Experiments across various scenarios demonstrate this method's efficacy in achieving real robots operations from human demonstrations in a zero-shot manner. The prompts of GPT-4V/GPT-4 are available at the project's website.